Hey everybody, here's some examples using Braun-Lemay-Burstin table 24.1 to kind of explain what's going on with with the four different types of aromatics or four different types of hydrocarbons that we talked about. Okay, and so we have, like in here, we have alkanes, alkenes, alkynes, and aromatics. Okay, it gives us bond angles. Okay, if you remember Lewis structures, the bond angles 109.5, that is a standard sp3 hybridized bond angle. Okay, and then it gives you the bond length between carbon and carbon, and so that's kind of interesting. And so what this does is gives you an idea of what happens as we add the number of bond, or as we change the number of bonds in the carbon backbone. And so in each of these cases, we're using just the 2-carbon version of it. Notice here, this is the longest bond. This guy is the next longest, and then we have the shortest of all of them is the triple bond. So this only has one pair of electrons holding that together. Okay, that means that it's not as tightly held as something like this guy, which has 2 pair of electrons, okay? And this has 3 pair of electrons holding it together. The more pair of electrons holding it together, the tighter and the closer that it is, okay? And now we come down to this aromatic thing, and remember, aromatics are very kind of special, and so the electrons here that are here making this double bond, they're delocalized, so the electrons spin, 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 spin. So it's not like this is a double bond and this is a single bond. What we know is each of these bonds are the same length because the electrons are delocalized. And so if we think about it, it's not it's not a double bond and then a single bond and then a double bond and then a single bond and then a double bond and then a single bond. Okay? It's kind of like a bond and a half all the way around. So the bond length here between this is something in between having 1 pair of electron and 2 pair of electron holding those carbons together. So it's kind of interesting how all of this works. Okay, but the bond angles are kind of as you would expect. Okay, and so it's 109.5 for this guy. It's right around 120 for this guy, sp2 hybridized, and this is going to be around 180. Okay, this guy is exactly 120. So there's nothing bizarre about any of these if you know your Lewis dot structures and you know your rules of your Vesper theory and geometries. Okay, so that kind of goes over some of the physical properties of of all the different types of hydrocarbons, and hope that helps you out a little.